Okay guys, so we have seen some introductory part of deep learning. Now let's go deep and start with our main course from this lecture. Alright, and guys, I must tell you like first 2, 3 or maybe 4 lectures will be a little theoretical part, and then we will be moving towards our practical and our projects part. Because these theoretical parts are must, like you should have a good knowledge on this to understand, basically to understand deep learning, as well as if you want to crack any interview, like basically they'll ask for your, if you clear any practical thing, then finally there will be a theoretical round in which they'll ask you all the theoretical things, so that's equally important in deep learning. So uh, for the starting 3 to 4 lectures, I'll keep like I'll be focusing mostly on theory, and then we'll move towards the practical. All right, so now let's see. Let me just put the heading as deep learning. Okay, so so far you have seen that when we talk about deep learning, we are talking about your neural networks, right? So whenever we are talking about deep learning, you are nothing but talking about your neural network. Now let's see the history, how exactly deep learning came into the picture. Okay, so in 1957 there was a concept of, like I have explained in my introductory video, there was a concept of perceptron. Okay, so which came into existence. This perceptron is almost very similar to what you have learned in your logistic regression. In basically in your machine learning, you have already seen logistic regression. It is almost very similar to that, and I will show you how they are similar in coming lectures, like how, like what part is similar between them. So there was a guy, Alan Turing. I hope most of you who entered this field, they must having a good picture about this guy, Alan Turing. He was the researcher behind it, about the perceptron. He was the researcher, like he started with the perceptron thing, then it was carried out with some of the other people or the researchers, but he started this perceptron thing. Okay, and he thought that humans got a brain, and due to this brain we are able to think and able to make decisions and so on. So let's try these features of brain to our computers somehow, so that computers can also try to achieve what our brains can do. I hope you're getting what I'm trying to say here. So what he did, he started working on it, and basically he went digging deep into how exactly human brains work. So he studied deep into your human brain. Okay, so he started digging deep into what how exactly it works. And during this time period when he was doing this study, he find out, like obviously with his team, he find out that he find out some very interesting thing about it, which was the neuron. Like I have shown you the example of neuron. Like let me just draw the brief, like let me just try to make a small neuron here, just an example. Okay, exactly it doesn't look like this, but I'm, like, you understand, right, what I'm trying to convey here. These are your dendrites. This is your nucleus. This is your axon, and these are again your dendrites. Okay, so uh, like I have told you that dendrites uh, like take all the inputs from other neuron here in our brain, it pass to your nucleus through, and it pass to your nucleus and do whatever the function it wants to do inside your brain, and then it pass to your other body parts, or from your body parts to the brain through axon. This is basically we have seen in the last lecture. So, and also I have shown you how it exactly works. Like if you touch something hot, it suddenly says like, okay, this is hot, remove your hand, it will pain, or it will, like, your skin will get damaged, or it will turn red. So basically, if you touch something hot, it will say in within fraction of seconds, not even a second, it takes a fraction of second to tell you that, and you react accordingly, right? And and you all know about one thing as paralysis, right? When any person has paralysis, let's say he has a paralysis in his hand, let's say in his right hand, and now he like somehow touch a hot body, he won't feel anything. Like, he keep on touching, obviously the skin will get damaged, but the neurons inside the hand are completely dead, and that is why he has the paralysis. So there will be no transfer of information to the brain that, okay, remove your hand because it's hot. So brain will not reply accordingly. All right. So I hope you are getting a picture about the neuron thing now. So let me just erase this. Okay. So what is happening inside a brain? Let's say I have few inputs here. One, two, three, and let's say there are many inputs. This is your x1. This is your x2. This is your x3 and x. Let's say xn. This is xn. Okay. And so we have, let's say we have x1, x2, x3 up to xn are the inputs coming to the brain. And let's say our brain is now calculating the all the inputs like touches. So he's doing some calculations here. Let's say he's doing summation of all the calculations, or let's say it's a function. And all the inputs are going to the brain. Okay. And and like now the brain will figure out whether it will pain or feel something. Like accordingly it will feel something, and then it will give you an output. Like if it pains, so hand remove your hand from that, it will pain, or it will turn red, or you'll feel irritated. Accordingly it will do the same. So this is how exactly your neural network also works and look like. And that is why I said your entire brain structure, the neuron part, is very similar to your deep learning. And that is why deep learning is also known as a deep neural network. So, neural network is something which is inside your brain, and deep learning is also known as deep neural network. I have already shown you the in all these in introductory videos, but those who are directly going from the first lecture, so I'm just revising some of the other topics here. Deep learning is also known as deep neural networks, and this is your simple neural networks inside your brain. This is just a one neuron I just zoomed in. There are millions and billions and trillions of neurons available inside your brain. Okay. So what will happen in my perceptron or your neural network? We're gonna have a lot of inputs coming, and it will give some sort of outputs. Like what happening? We have a lot of inputs. Lots of inputs will be coming to the brain, and we have some outputs as well. Let's say we have some outputs. So this is how your perceptron, at that time your perceptron was working. So in short, if I draw a neural network, if I want to draw some neural network, it will look like this. Let me draw it. uh, starting 3-4 lecture, guys, can be a little boring, but if you want to learn deep learning, these concepts are very, very important. I'll try to make everything very easy. Okay, so your each input will talk to all your others, uh, basically nodes. This will talk to these two, this will also talk to these two, and this will also talk to these two, and finally they both will give some output, and then final result will be out. So in short, this is how your neural network looks like. Neural network. This is just a simple schematic diagram to explain few things. Okay, so now if I go back to my that brain example, when I zoom the neuron, we have nucleus there, we have inputs as dendrites, and we have outputs as axons in our neuron. This is a simplified version of neuron. Now we were getting some inputs. Now like here we are getting some inputs. Let's say x1. Okay, I'll just first let me explain one more topic here. Like I have explained before in the previous lecture, wherever the input is going on, like this is your input. We are giving the input here. So basically this is your input layer. Here we are getting the output. So this is your output layer. And between input and output, you have your hidden layer. Okay, so you are clear up to this. And if you make along with me, that's well and good. It will be in your mind for a long time. It will stay in your mind for a very long time. All right, so let me just erase it. You can pause the lecture and draw all these things. Now, if I want, if I uh, let's say if I'm getting some inputs here. I have this as a nucleus, and I'm getting some inputs. Okay, and let's say x1, x2, x3, and x4 is my input, are my inputs. And let me assign the lines here as well. Okay, and I'm getting two outputs, not much. I'm just trying to explain a concept here. I'm getting two outputs. I'm saying naming it as O1 and O2. All right, and this is my function. Let's say your brain was calculating something, or basically it is a function. And also we have corresponding weights, W1, W2, W3, and W4. Remember guys, I explained you how exactly your weight works. Weight can be increased or decreased as per, like I gave you one child example, a kid example, in which his parents told him not to touch that hot body, so the weight was less. Inside his mind he was like taking this thing as not seriously. He was not taking these things seriously. He was saying okay. So at that time weight was very less, but when he touched it and feel the pain, the weight suddenly become huge. So that was a simple example to explain how exactly what is weight and how it works, right? So, and in the nucleus part here, we used to apply some sort of functions, and in neural network we started calling it as this part. Like we call, in brain we call it as a nucleus, but here we call it as activation function. This is very important, guys. You should make a note. Activation function. This is nothing but your activation function. Okay. So, and I've explained O1 and O2 are your outputs. So if we take one output and study that, I'm just taking O1. Okay, I'm just taking O1 and study that only one output. If we focus and study on it, we are getting O1 as function of W1 x1 plus W2 x2 plus W3 x3 plus W4 x4 and so on. Like in this case, it will be up to 4, W4 x4. Now, if you can recall from your machine learning, we already know this. We already know this formula, right? If it was a linear regression, if it is a linear regression, the f here is called the identity function. You can recall it from your machine learning lectures, right? Identity function. And if it is a, let's say, logistic regression, your f is a sigmoid function. I hope you remember all these things. So basically, your this function, entire function f depends on, like, whatever you put, it depends on it. So this f becomes my activation function here. So there are lots of them. Lots of activation functions are there that we will be learning, and we will be figuring out which one is better and which one we should use here in our any project or model we are working on. All right, so this is how exactly it works. These are your inputs x1, x2, and x3, and these are your corresponding weights to it. We have passed it through an activation function. Let's say x1 is your pain, like you are touching a hot body. X2 is you are eating ice cream. Similarly, at the same time, and third is you are doing something like you can feel all the feelings you are transferring to the brain to process with all the required weights, and then brain will give the output like, okay, similar, like I'm just trying to explain you, right? So this is how exactly your activation function looks like, and how we can relate it to your linear regression and logistic regression. In short, how we can relate it to your machine learning concept. Okay, so now if I want to mathematically write this equation in short, mathematically, I hope guys you are noting down. So your output O will be F summation of I from 1 to N Wi xi. Now you know O is your output, W is your weights, xi is your input, and F is your function. Or let me just write it down. It will be easy for you to remember. This is your, let me say, X is your input. Whatever the values you are inputting, you're putting are your x, like x1, x2, and x3, and x4. Whatever you are putting are your x. W's are your corresponding weights. F is your activation function, which I just explained what it is and how we can relate it to your machine learning. And O here is your output. I want you guys to please make a note of this by pausing the video, or anything you want. Please make a note of this. Okay. So from a perceptron, you can calculate your, you can say your linear regression or logistic regression. You can do that, right? From your perceptron only. So in short, if I want to note this down, from a perceptron, you can calculate LR, right? So now, if I want to give you another example, let's say I have some multiple weights coming. Let me just make a diagram here. I have multiple weights coming here with multiple inputs. This is my, I'll just denote like this. Okay, so this is my, let's say it was xi, so let's say xi1, xi2, xi3, xi4. These are my inputs, and corresponding I have weight 1, w2, w3, and w4. And this is my activation function here. It will give you an output y cap. Let's say y cap. So I have multiple weights coming in this form and passing through a function f here, and we have some inputs as well. So this is my equation here. So if I want to represent my perceptron mathematically, how I will do that is I will say yi, which is your output, yi cap equals to f w1 xi1 plus w2 xi2 plus w3 xi3 w4 xi4. And let's say I have like one more function here, like the equation is y equals to mx plus c. So let's say I have one more function as the weight is 1 and input is b, so like mx plus c, so 1 into b. Okay, so we can also write this equation as, this is nothing but what I have explained you right few moments back. O equals to f summation of I equals to 1 to n wi xi. Just compare. O is your y cap, y cap. Here you can see it is O. F is a function, activation function. These are all the summation of the words, and then there is a mx plus c. C is your constant, and I'm saying as weight is 1, and I'm just to give you an example here. Okay, so we can also write it as y I y1 I y or yi cap equals to function of wx I transpose plus b, right? I can write like this as well. So this is how you can represent your perceptron mathematically. Also, these things you already know from your machine learning background. And I'm doing nothing different. I'm just connecting dots with your deep learning and machine learning. Like, so guys, you may find it like starting 3 4 lectures, you may find little boring and a lot of theories, but I can't help it, right? You have to learn. Like, if you want to learn deep learning, you have to do that. Even if you learn it by your own and try to learn it by your own from books or something, it will be more complicated. Here I am simplifying the things by giving some of the other analogies or examples like that I given as a kid example. So that's what I'm trying to do for the. So guys, I would request you to please bear with me for like starting 3 to 4 lectures only. After that, when we'll come to your captcha building, image recognition, and all those projects that we will be seeing, those are so interesting with all the coding parts and all that you will enjoy a lot. But for that, to complete that, otherwise, if you jump directly to that, you won't understand anything what I'm trying to explain there, right? So if I use the word ReLU there, so you don't know the ReLU is an activation function which I will be explaining in coming videos, like next video or maybe next to next video. So here that so to learn this, what I did, like what strategy I used to learn all these things, I usually like note everything down, and and I used to make notes in my own words, like in my own words, and I make it in detail. Like, I explain whatever I learned, I explain myself and note that thing down. You can also do the same, and if you're not getting it, this is not something like out of the world. Watch the lecture, or the part of the lecture which you are not understanding, watch it 2 times or 3 times or 4 times. Take your Sunday, Saturday, weekends off. Focus mostly on deep learning if you are busy during the weekdays. Just for the starting 4 or 5 lectures. That's it. If you understand starting 4 or 5 lectures, your entire deep learning will go very smoothly. Okay, and if you are getting any problems with Python, so I do run a Python from the basic for data science domain. I do run a course of that. You can always go and take the Python lessons if you're very new to Python. Otherwise, if you can understand, that's well and good. Okay. So basically, I'm not doing, like I have already explained, I'm not doing anything different here. I'm just connecting dots of your machine learning with your deep learning. Okay. So let me just erase the screen here. Okay. So guys, now if you remember from your SVM in machine learning, from your SVM in your machine learning, you have something like this. Let me draw it. These are nothing but your data points. And this was a straight line passing somewhat like this. Okay. And if you remember from your machine learning, uh, we have something like, let's denote it as O is equals to W1 x1 plus W2 x2 and so on. We have something like this, right? And I'm just denoting it as O. So if your O is greater than 1, if O is greater than 0, sorry, not 1. Okay, no, I should not take O because it's looking weird now. Let's say Q. So if your Q is greater than 0, it will come at this area, the top one. If your Q is equals to 0, it will be on this line. and if your q is less than 0, it will go under the line. I hope you can recall this from your SVM, from your machine learning concept. So same thing happens in your perceptron as well. I'll show you. Same thing is there in perceptron. And here, if I have to define function f of any input, I will say my f will be 1 if my wxi transpose, which I have just explained you in the previous slide, plus b is greater than 0, and else it will be otherwise. So just defining it more mathematically. I'm doing nothing, I'm just defining it more mathematically. Perceptron. Okay, so this is how basically you can work with all the concepts here and what is perceptron and how it works. So guys, next topic which we will be seeing is your multi-layered perceptron, or your multi-layered perceptron, or you can simply say MLP. So it will take around 1 hour, or in fact more than 1 hour. So I'm just stopping this video here because I don't want to exceed my lectures for 1 hour. So it will be very like, students don't like to go in a short if they want to take the lessons. They love short and simple lessons, but I usually go for 1 hour or 45 to 50 minutes lectures. So we will be seeing this in the next lecture, multi-layered perceptron, and we will be learning everything in detail. But before that, I want to show you what exactly we will be seeing here in our machine learning syllabus. Let's say I have a, I'll show you one data set with me. Okay, so I have this pet image. So we will be, if I get time, or if you can understand this, like, I'll see, I'm building a course here, so if I'll see if we can explain this thing. I'm working on this. So you can see this is my 374 MB cat folder, and this is my almost 450 MB dog folder, right? So in cat folder, if you open it, there are like 12,500 images of cats. Yes, almost all the images are like 90 to 95% images are different. You can see that right here. Okay, so this is your cat folder, and similarly you have one dog folder. I'll show you, like, if we will work on this project, so I will show you how to download, where to download all this, or else I'll like put a Google Drive on my Google Drive. I'll put this and I'll share with you guys. If you want, you can ask me. So these are some 12,500 again pics of your dogs. So basically, if I say click on this, your computer won't understand like this is a dog, or this is a dog, or this is a dog. It won't understand. So in your deep learning, what I have built a model in which, if among like there are 12,000 pictures, 12,500 pictures of cats and 12,000 pictures of dogs. So in total, there are 25,000 pictures. So among 25,000 pictures, I am going to train my model, that might basically my deep learning model, like let's say from 25,000 I'm training with 22,000 pictures of cats and dogs, and I'm giving the features like that I'll show you then when we'll move into this part of section, that I'll show you, and the final result will be if you pass any picture, like let's say if you pass a picture like this is very difficult to understand, right? It's a cat or a dog, like if you, like humans can do that. Let it open. Yeah, it's like this is not clear, and an entire dog is a black colored dog. Even eyes are not visible. Like for us, if we zoom it, it can. What happened? I lost where the dog went. Ah, yeah, he's lying here. Okay, so if I zoom it, so then we can see there is a eye here and the. But your, if I even I train my model, it will be very difficult for my model to guess where is the eye, where is the nose in this particular picture, and that's where it comes for the accuracy part. So our model will be, if our model is more than 85% accurate or 90% is well and good, or even sometimes 80%, it will show you, if you pass this picture, it will show you it is a dog. This is very simple example of image recognition that we will be seeing. And if you pass this, it will say this is a cat. But there are few chances in which, like, cats also have such ears, sharp pointed up ears. Cats also have a tail, and so like there are some other features that we will be defining that will differentiate between cat and dog. So there can be chances, like if you place the picture of cat and it will, your model will say it is a dog. So that means your model is not so accurate that it is not, it is getting confused now between your cat and dog. So we will see, we'll build a model and we'll see that. Also, we will see how to build your own captcha. Like whenever you enter or you submit any project, you have to enter a captcha, right? Any number or alphabets which are not like jumbled, or you understand, right? Captcha. We will be creating that entire captcha model. So that is basically known as amnest. Like we will be pulling up the data from amnest. Amnest is nothing but there is a huge collection of handwritten numbers which we will use to build our captcha. So I will be explaining you that as well. But first, I would like you to please focus on theoretical parts, because if your theory is not clear, you will be stuck a lot in your practicals. Like you have to again finally you have to go and look the theoretical section. So why not learn it in the first time? All right. So now let's end the lecture here, and in the next lecture you will see multi-layered perceptron, or MLP in short. It is very important lecture. So you can go ahead and have a look on this. Before that, make a note of this and clear up this. So thank you so much, guys. See you in the next lecture.